Matatag Curriculum, Science Grade 4, Quarter 1, Lesson 4, Materials and Their Uses. Hello, how are you today? Are you ready for today's lesson? Then, let's start. Our topic in Science 4 is about materials and their uses. This is Teacher Aika, your online teacher. Learning competency. Describe changes in properties of materials when exposed to certain changes in temperature, such as changes when wood or coal is burned. Here are the objectives. A. Describe changes in matter that involve physical change and chemical change. B. Investigate to show how changes in properties of materials occur when exposed to very high or very low temperatures. C. Cite situations wherein phase change is beneficial. Before we start the lesson, let's have first a short review. You will recall your prior knowledge of the characteristics of the three states of matter: solid, liquid, and gas. Instructions: complete the table below by describing the characteristics of solids, liquids, and gases. Give examples for each state. So we have here the table: states of matter, solid, liquid, and gas. You need to give the characteristics and examples. And here are the answers. Solid, characteristics, definite shape and volume. Examples: ice, rock, book, toy, and chair. Liquid, characteristics, take shape of container. Examples: water, juice, milk, oil, and syrup. And last, gas. Characteristics, fills the container. Examples: air, steam, helium in balloons, carbon dioxide, breathe out, nitrogen in the atmosphere. Good job, kids! This time, let's talk about the states of matter. Let's first have solid. Solids hold their shape, they do not flow and do not take the shape of their containers. Examples: solids are paper, coins, books, and pencils. The next state of matter is about liquid. Liquids are objects that flow. They take the shape of the containers that hold them and fill the container starting from the bottom. They do not float, and they can be held in a container even with an open lid. Examples of liquids are water, oil, and alcohol. The third state of matter is gas. Gases take the shape of their containers. When placed in a container with an open lid, gas particles will go out or escape the container. Gases are usually light and can float around in space. Many gases cannot be seen. The air that we breathe is an example of a gas. Matter undergoes various changes when exposed to changes in temperature, which can be classified as either physical or chemical. In the next phase of the lesson, you will be able to know and understand how these changes in matter happened. It could be a change in its internal structure or physical appearance. It may also result in the formation of new materials when they are mixed. Let's try this activity. Rearrange the letters to create a word corresponding to the word given by the teacher. So here's the first one. It is to make or become different. What is the answer? It's change. Correct. Number 2, it is a measure of how hot and cold something is. What is the answer? Correct. Temperature. How about number 3? It is a type of food with a limited shelf life if it's not refrigerated. What is the answer? Correct. Perishable. Number 4. It is a process in which one or more substances, the reactants, are converted to one or more different substances, the products. What is the answer? Correct. Chemical reaction. Number 5. It is the chemical reaction that occurs between substances when materials burn. The correct answer is combustion. Good job! Let's talk about first physical change. Remember, a physical change in matter is a change that affects one or more physical properties of a substance without altering its chemical composition. One of the changes that can happen in matter is a state of change. A solid object can turn into a liquid or a gas. A liquid can turn into a solid or a gas. Last, gases can turn into liquids or solids. When exposed to very high or very low temperatures, these changes happen to materials. A physical change in matter can involve a change in state. For example, a solid can change into a liquid or a gas. Second, a liquid can change into a solid or a gas. And third, a gas can change into a liquid or a solid. This time, let's take a look at these examples. Solid to liquid, ice melting into water. Solid to liquid, chocolate melting when heat. liquid to solid, water freezing into ice. Liquid to gas, boiling water turning into steam. Gas to liquid, water vapor condensing into liquid water on a cold surface. As the temperature increases, the ice absorbs heat energy from its surroundings, causing its molecules to gain energy and move more freely, thus changing from a solid to a liquid. And here are the guide questions. Number 1. What is the natural state of the cubes? Here's the answer. The ice cubes are currently solid. When they get warm, they will melt and turn into liquid water. Number 2, can you describe the properties of the ice cubes? Example, solid, cold to touch. And here is the answer. The ice cubes are: first, solid. They hold their shape. Cold, they feel very chilly. Hard, they are not soft or squishy. Number 5. Can you describe any changes in the appearance or texture of the ice cubes? Here's the answer. As the ice cubes melt, the appearance, they started to look smaller and wet. For the texture, they become soft and slippery as they turn into liquid. Let's talk about melting. Melting happens when something solid turns into a liquid because it gets warm. For example, first, ice melting. Ice cubes turn into water as they warm up. Appearance, ice cubes get smaller and turn into a puddle of water. And third, the texture, the ice becomes soft and wet. In the demonstration, the ice cubes melted when exposed to high temperatures and turned into liquid or water. Melting is a process where a solid turns into a liquid when it gets warm enough. When something melts, it becomes soft and turns into a liquid. For example, when ice cream melts, it becomes liquid instead of being hard like ice. And here are the examples of melting. Ice melting. Ice melting. One common example of melting is when ice cubes are left outside on a warm day. As the sun shines on them or the temperature gets warmer, the ice cubes start to melt and turn into water. Next is chocolate melting. Chocolate melting, another example is when you heat chocolate in a microwave or over a stove. The solid chocolate turns into a liquid, making it easier to spread or use for making desserts like chocolate covered strawberries. Next is candle wax melting. When you light a candle, the heat from the flame melts the wax. The melted wax then drips down the candle, creating a pool of liquid wax that fuels the flame. And here are the real-life applications or uses. Cooking. Melting is used in cooking to transform solid ingredients into liquid. For example, butter is melted before adding it to cake batter, or melted cheese is used as a topping for nachos. Next is making popsicles. Melting is involved in making popsicles. You pour liquid juice or flavored water into molds and then freeze them. When you take them out of the freezer and let them sit, the popsicles start to melt, turning back into liquid. Next is recycling. Melting is used to recycle materials like aluminum and steel. Scrap metal is melted down at high temperatures to make new products, like aluminum cans or steel beams, instead of throwing it away. Arts and crafts. Melting can be used in art and crafts projects. For example, crayons can be melted and poured into mold to make a new crayons with different shapes or colors. In the demonstration earlier, if the melted ice cubes, which have turned into liquid, are continually exposed to high temperatures, the liquid will eventually turn into gas. Evaporation is when the liquid turns into a gas. This happens when the liquid gets warm enough and its molecules move so fast that they escape into the air as vapor. You can think of it like tiny invisible water particles flying away from a puddle, a cup of water, or even wet clothes when they're left out. And let's talk about evaporation. Evaporation is when a liquid turns into a gas because it gets warm. For example, water from a puddle disappearing into the air when it's sunny. Here are different examples. First, we have drying clothes. After washing your clothes, you hang them outside to dry. As the sun shines on them and the air around them gets warm, the water on the clothes evaporates and they become dry. Puddles disappearing. After it rains, you might notice that puddles on the ground disappear, even if it's not sunny. This happens because the water in the paddle slowly evaporates into the air. Next is steam from boiling water. When you heat water on a stove to make tea or cook pasta, steam rises from the pot. This steam is water vapor formed because the water is evaporating. Next, we have swimming pool evaporation. Have you ever noticed that a swimming pool gets lower over time, even if nobody takes water out? This is because water evaporates from the surface of the pool, especially on hot days. That's why sometimes we need to add more water to keep the pool full. Drying wet surfaces. If you spill water on the kitchen counter or the bathroom floor, you can wipe it up with a towel. But what happens if you leave it there? Eventually, the water evaporates and the surface becomes dry again. Next, we have making salt. Ever heard of the sea salt? It's made by evaporating seawater. When seawater is left out in the sun, the water evaporates, leaving behind salt crystals. These crystals are collected and cleaned to make the salt we use in cooking. Now let's talk about freezing. Freezing occurs when a liquid turns into a solid when it gets cold enough. Imagine water turning into ice when it's left in the freezer or outside on a cold winter day. The cold slows down the molecules in the liquid, making them stick together and form a solid. And here are the examples of freezing. Making ice cubes. One common example of freezing is making ice cubes. You pour water into an ice cube tray and put it in the freezer. The water freezes and turns into solid ice cubes as the water gets cold. Freezing popsicles. When you make popsicles at home, you pour juice on flavored water into molds and put them in the freezer. Over time, the liquid freezes, turning into tasty frozen treats. Ice cream. Have you ever seen an ice cream machine at an ice cream shop? It works by freezing a mixture of cream, sugar, and flavors while stirring it. This makes creamy ice cream that you can enjoy on a hot day. Preserving food. Freezing is a great way to keep food fresh or for longer. You can freeze fruits, vegetables, meat, and leftovers to prevent them from spoiling. This way, you can enjoy your favorite foods even if you can't eat them right away. Keeping cool. Ice and frozen treats are perfect for keeping cool on a hot day. Whether you're drinking a cold glass of lemonade with ice cubes or enjoying a frozen dessert like ice cream or popsicles, freezing helps us stay refreshed when it's hot outside. Next, we have transporting perishable goods. In places where it's hard to keep food fresh, like during long journeys or in remote areas, Freezing is used to preserve perishable goods. Foods like meat, fish, and vegetables are frozen before being transported to keep them from spilling. Making frozen treats. Freezing is essential for making all kinds of delicious frozen treats, such as ice cream, sorbet, frozen, yogurt, and gelato. These treats are enjoyed by people all over the world, especially on hot summer days. Remember, understanding freezing helps us know how liquids can change into solids when they get cold, and it's useful for keeping food fresh, staying cool, and making tasty treats. Let's have the lesson activity. Divide the class into 5 groups. Each member of every group will decide on the specific role that they will play within their group or team jobs. Along with each role are color-coded visors with their corresponding meaning. Manager, color red; speaker, blue; director, green; and reports coordinator for yellow. Good luck! And here's the lesson activity. Provide each group with a copy of the activity titled Changing State of Matter. Remind the teammates of their roles. Next, students perform the activity as directed and answer the questions provided in the worksheet. And third, ask the students to present their output in class. Here's the activity sheet, Changing State of Water. Objectives: at the end of the activity, the learners are expected to describe changes in water that involve physical change. The materials needed are the following: ice cubes, saucer, handkerchief, small basin, glass, sheet of paper, water, small plastic bag or ice candy bag. Instructions: work in group together with your teammates, perform the activity. And here's the procedure. Number 1, take 3 ice cubes, place them in saucer. Number 2, put the saucer with ice cubes directly under the sun. 3, wait for 10 minutes, observe what happens to the ice cube. And number 4, based on your observations, answer the following questions. Here's the part B. Number 1, put water in a small basin. Number 2, soak the handkerchief in water until it is totally wet. 3, place the wet handkerchief directly under the sun for 1 hour and observe what happens to the handkerchief. And number 4, based on your observations, answer the following questions. Here's the part C. Number 1, fill half of a small plastic bag with water. Number 2, place in the freezer overnight. Number 3, after 1 day, remove the small plastic bag from the freezer and observe what happens to the water inside. And number 4, based on your observations, answer the following questions. Complete the table below based on your observations in the activity. Part A, Part 2, or Part B, and Part C. Present your findings to the class. Good luck! Here are the guided questions. Number 1, what happened to the ice cubes when placed directly under the sun? Number 2, what do you call this process? Number 3, what happened to the wet handkerchief when placed directly under the sun? Number 4, what do you call this process? Number 5, what happened to the water inside the plastic bags after leaving it in the freezer overnight? Number 6, what do you call this process? And here are the answers. Number 1, What happened to the ice cubes when placed directly under the sun? The answer: when ice cubes are put under the sun, they melt and turn into water because the sun warms them up. Number 2, what do you call this process? This process is called melting. Number 3, what happened to the wet handkerchief when placed directly under the sun? The answer: when a wet handkerchief is placed under the sun, it dries out because the sun's heat makes the water evaporate. Number 4, what do you call this process? The answer: this process is called evaporation. Number 5, what happened to the water inside the plastic bag after leaving it in the freezer overnight? The answer: the water inside the plastic bag will freeze and turn into ice after being left in the freezer overnight. And last, number 6, what do you call this process? Answer: this process is called freezing. This time, let's talk about chemical change. Chemical changes make new things. For example, when you bake cookies, the dough turns into cookies, which are different from the dough. Physical changes just change the way something looks, but it stays the same. For example, when ice melts, it turns into water, but still, it's water. So chemical changes create new stuff, while physical changes only change how things look or feel.
In simple terms, combustion is the burning of something. Let's take a look at the combustion of wood. Wood is made up of a bunch of different compounds that contain mostly carbon, hydrogen, and oxygen atoms. And these compounds are held together by bonds. When wood is heated, usually from the heat of a match or a lighter, some of the bonds break, and as a result, different chemical compounds are released as vapor into the air. When these vapors mix under high heat with oxygen from the air, they burn and release more heat and also produce carbon dioxide and water. This is what sustains the flame of the fire. And if all that wood gets converted to carbon dioxide and water, it's called complete combustion. However, complete combustion of wood never happens. Combustion is not an instantaneous process. In addition to fuel, oxygen, and heat, combustion also takes time. So, if any of these conditions are not met, then the vapors from the wood combine with the oxygen and nitrogen in the air, and they form other kinds of molecules and compounds, like carbon monoxide, nitrogen oxides, as well as unburned fuel and particulates or black carbon. These types of compounds are what make up smoke, which is bad for the environment and for human health.
And here is the example. When wood burns, it creates three main products. First, carbon dioxide. This is a gas that goes into the air and can make plants grow. Second, water vapor. This is a gas that comes from the steam in the burning wood. And third, ashes. These are the solid bits left behind after the wood has burned. Oxygen is very important for burning. It helps in the chemical reaction that makes fire. Here's how it works. Number 1, fuel and oxygen. For something to burn, it needs fuel, like wood, and oxygen from the air. Number 2, reaction. When the fuel and oxygen mix and get hot enough, they react together. This reaction releases energy in the form of heat and light, which is the fire you see. Number 3, continuous burning. As long as there is enough oxygen, the fire keeps burning. If you take away the oxygen, the fire goes out. So, oxygen helps start and keep the burning process going. Without oxygen, the burning wouldn't happen. Burning wood and other materials releases carbon dioxide or CO2 into the air. CO2 is a gas that traps heat and makes the earth warmer, which can lead to climate change. This warming can cause problems like melting ice and extreme weather. So, while burning things gives us energy, it also adds CO2, which affects our climate and environment. Here are the guide questions. Number 1, what changes do you see when we light the wood on fire? Number 2, describe the color of the flames. Are they the same throughout the burning process? Number 3, do you notice any smoke? What do you think is causing it? Number 4, how does the wood change as it burns? Does it look or feel different? Number 5, what do you see left behind after the wood has burned completely? Number 6, can you describe the ashes? What do you think they are made of? Number 7, based on what you observed, do you think burning wood is a chemical change or a physical change? And why? Number 8, what do you think happens to the wood molecules during the burning process? And number 9, can you name any other examples of chemical changes that you have seen or heard about? And here are the answers. Number 1, what changes do you see when we light the wood on fire? Here's the answer. When we light wood on fire, we see it start to burn with flames. The wood gets smaller and changes into ashes and smoke. Number 2, describe the color of the flames. Are they the same throughout the burning process? Here's the answer. The flames are usually orange or yellow, and sometimes they have blue or red parts. The color can change as the fire burns. Number 3, do you notice any smoke? What do you think is causing it? And here's the answer. Yes, we see smoke rising from the fire. The smoke is caused by the wood burning and turning into gases. Number 4, how does the wood change as it burns? Does it look or feel different? Here's the answer. As the wood burns, it changes from solid pieces into a soft, glowing fire. It feels hot and looks different from when it was just wood. Number 5, what do you see left behind after the wood has burned completely? Here's the answer. After the wood has burned completely, we see ashes left behind. These are the leftover bits after the wood has turned into smoke and gas. Number 6, can you describe the ashes? What do you think they are made of? Here's the answer. The ashes are light and powdery. They are made of the leftover parts of the wood that didn't burn completely. Number 7, based on what you observed, do you think burning wood is a chemical change or a physical change? And why? Here's the answer. Burning wood is a chemical change because it creates new things like smoke and ashes, and the wood turns into different substances. Number 8, what do you think happens to the wood molecules during the burning process? Here's the answer. During burning, the wood molecules break apart and mix with oxygen to make new gases and ashes. Number Number 9, can you name any other examples of chemical changes that you have seen or heard about? And here is the answer. Burning wood is a chemical change because it creates new things like smoke and ashes, and the wood turns into different substances. Let's talk about examples about chemical change. First, we have toasting bread. When bread is toasted, it undergoes a chemical change. The heat causes the bread is to turn golden brown and crispy. The high temperature of the toaster or oven changes the bread's color and texture, creating new flavors. Roasting marshmallows. When marshmallows are roasted over a campfire, they undergo a chemical change. The heat makes them melt and turn brown on the outside. The heat from the fire transforms the marshmallow's texture and taste, making it gooey and delicious. Baking cookies. When cookie dough is placed in the oven, it undergoes a chemical change. The heat causes the dough to rise and turn into cookies. The high temperature of the oven changes the dough's composition, turning it into a tasty treat. Caramelizing sugar. When sugar is heated in a pan, it undergoes a chemical change called caramelization. The sugar melts and turns into a golden brown liquid with a rich flavor. The sugar changes color and taste as it is heated, creating a sweet caramel sauce for desserts like caramel apples or caramel popcorn. Popcorn popping. When popcorn kernels are heated on the stove or in a microwave, they undergo a chemical change. The heat causes the moisture inside the kernels to turn into steam, which builds up pressure and eventually makes the kernels pop. The high temperature transforms the hard kernels into fluffy popcorn, ready to eat as a tasty snack. Frying an egg. When an egg is cracked into a hot frying pan, it undergoes a chemical change. The heat causes the proteins in the egg white and yolk to denature and coagulate, turning from a liquid to a solid. The egg changes texture and color as it cooks, becoming a delicious breakfast food that can be enjoyed sunny side up, scrambled, or fried. Here are the benefits of chemical changes. First, we have cooking food. Chemical changes occur when we cook food, turning raw ingredients into tasty meals. For example, when we bake cookies or grill burgers, the heat causes chemical reactions that make the food taste delicious and safe to eat. Next, making new materials. Chemical changes helps us create new materials with useful properties. For instance, baking soda and vinegar react to produce carbon dioxide gas, which makes baked goods rise and become flappy. Producing energy. Chemical changes are essential for producing energy. When we burn wood or fossil fuels like coal or natural gas, chemical reactions release heat and light energy that we use for heating our homes, cooking food, and generating electricity. And here are the harmful effects of chemical changes. Of course, we have pollution. Some chemical changes can pollute the air, water, and soil. For example, burning fossil fuels for energy releases pollutants like carbon dioxide and sulfur dioxide, which contribute to climate change and air pollution. Next is toxic substances. Certain chemical changes can produce toxic substances that harm living things. For instance, when plastic is burned, harmful chemicals are released into the air that can cause health problems if inhaled. Next, we have damage to the environment. Chemical changes can cause damage to the environment and ecosystems. For example, chemicals from factories or farms that get into rivers and oceans can harm fish and other aquatic life, disrupting the balance of ecosystems. Let's have another lesson activity. Divide the class into 4 groups. Each member of every group will decide on the specific role that they will play within their group or team jobs. Along with each role are color-coded visors with their corresponding meaning. Manager will have red, speaker blue, director green, reports coordinator is yellow. And here's the instruction. Ask the students to go over worksheet number 2, titled Unveiling Chemical Transformations with Heat. Remind the teammates of their roles, and students need to perform the activity as directed and answer the questions provided in the worksheet. Allow the students to present their output to the class. And here's activity number 2 or worksheet number 2, Unveiling Chemical Transformations with Heat. Objectives: at the end of the activity, the learners are expected to observe chemical changes in materials when exposed to high temperatures and identify evidence of these changes. Here are the materials needed: table sugar, test tubes, strips of aluminum foil, alcohol lamp, vinegar 500 to 1000 ml, baking soda, matches, piece of wood, beaker, liquid milk, tongs, steel wool, medicine dropper, pieces of recycled paper. And here's the instructions. Safety first. Ensure all participants are wearing safety goggles and understand the importance of safety when handling chemicals. Adult supervision is necessary throughout the activity. Work in group together with your teammates. Perform the activity. And here's the procedure. Part A, put a spoon of table sugar into a test tube. B, carefully light the alcohol lamp using a pair of tongs. Hold the test tube and place it over the flame of the alcohol lamp while swirling it, and observe. Part B, A, pour vinegar into a beaker until it is halfway full. B, place the steel wool or aluminum foil strips in the vinegar. C, feel the temperature of the beaker by filling it. Then, let it sit for 15 minutes. D, after 15 minutes, hold and feel the temperature of the beaker again. Part C, pour vinegar into a beaker until it is halfway full. B, add a spoonful of baking soda to the vinegar and observe. Part D, pour vinegar into a beaker until it is 1/4 full. Add 10 drops of liquid milk to the vinegar and let it sit for at least 5 minutes. Part E, get a piece of wood. Letter B, carefully light the alcohol lamp using a pair of tongs. Hold the wood over the flame of the alcohol lamp and observe. Part F, get a piece of recyclable paper and using matches, carefully light the paper and observe. Based on your observations, complete the table and answer the questions below. Part A, B, C, D, and E, and F. Write your observations and evidence of chemical change. And also answer the guide questions. And for the last part, we have conclusions. Based on the activity, what are the pieces of evidence of chemical change in materials or substances? Present your findings to the class. Good luck! And here are the guide questions. First, what happened when the material were exposed to high temperatures? Second, did you observe any color changes or other reactions? Third, how did the materials behave differently when burned? Fourth, were there new substances formed? What are these? And fifth, how might these reactions be useful in everyday life or science? And here are the answers. First, what happened when the materials were exposed to high temperatures? Answer: when exposed to high temperatures, materials often melt, burn, or change shape. Second, did you observe any color changes or other reactions? Answer: you might see color changes like flames turning different colors or materials changing colors as they burn. Third question, what did the materials behave differently when burned? Here's the answer. Materials burn and turn into ashes, smoke, or gases. Fourth, were there new substances formed? What are these? Answer: burning creates new substances like carbon dioxide, water vapor, and ashes. And sixth, how might these reactions be useful in everyday life or science? And here's the answer. These reactions help us in everyday life, such as in cooking, heating, and energy production. Let's have this activity. Outline in the graphic organizer what they have learned in the lesson. Utilize the graphic organizer below. Changes in materials, we have physical change and chemical change. Under physical change, we have melting, evaporation, and freezing. For chemical reaction or chemical change, formation of charcoal, rust formation, production of smoke, formation of ash, and formation of bubbles, creating or forming a new materials. And here is the answer. Changes in materials, the introduction, physical changes, and chemical changes. You can use it or you can use your own understanding about the lesson. Let's have a formative assessment. Directions: read each question carefully. Identify the letter of the correct answer. Number 1. Which of the following is an example of a physical change? A. Burning wood, B. Rusting iron, C. Melting ice cream, or D. Baking a cake? The correct answer for this is letter C. Melting ice cream. Number 2. What happens when you tear a piece of paper into small pieces? A. A chemical change occurs. B. The paper undergoes evaporation. C. The paper undergoes a physical change. Or D. The paper undergoes sublimation. The correct answer is letter C. The paper undergoes a physical change. Number 3. Which of the following is an example of a chemical change? A. Cutting vegetables, B. Melting butter, C. Mixing baking soda and vinegar, or D. Freezing water? The correct answer is letter C. Mixing baking soda and vinegar. Number 4. Sarah was cooking scrambled eggs for breakfast. She cracked some eggs into a hot frying pan and stirred them until they were cooked. What type of change did the eggs undergo during cooking? A. Physical change, B. Chemical change, C. No change occurred, or D. Both physical and chemical changes. The correct answer is letter B. Chemical change. Number 5. Timmy mixed some sugar into his glass of water until it dissolved completely. What type of change occurred when the sugar dissolved in the water? A. Physical change, B. Chemical change, C. No change occurred, or D. Both physical and chemical changes. The correct answer is letter A. Physical change. Number 6. Which of the following is an example of a physical change involving a change of taste? A. Rust forming on an iron nail, B. Paper burning and turning into ashes, C. Ice melting into water, or D. Milk spoiling and curdling. The correct answer is letter C. Ice melting into water. Number 7. Maria was baking cookies in the oven. As the cookies were baked, they turned golden brown and became firm. What type of change occurred to the cookies during baking? A. Physical change, B. Chemical change, C. No change occurred, or D. Both physical and chemical changes. The correct answer is letter B. Chemical change. Number 8. Alex lit a candle and observed as the wax melted and formed a pool of liquid around the wick. What type of change occurred to the wax during burning? A. Physical change, B. Chemical change, C. No change occurred, or D. Both physical and chemical changes. The correct answer is letter A. Physical change. These multiple choice test items cover various aspects of physical and chemical changes, including examples and situational problems to assess understanding. Number 9. Jason was cleaning his bicycle after a ride. He noticed that the metal parts were starting to rust. Why is it important for Jason to prevent rust from forming on his bicycle? A. To make his bicycle look shiny and new. B. To avoid damaging the metal parts of his bicycle. C. To impress his friends with his well-maintained bicycle. Or D. To win a prize for the best-looking bicycle. The correct answer is letter B. To avoid damaging the metal parts of his bicycle. Number 10. Anna was planning to cook dinner for her family. She needed to know whether cooking chicken in the oven would result in a physical or chemical change. Why is this important for Anna to consider? A. So she can impress her family with her cooking skills. B. So she can choose the best cooking method for the chicken. C. So she can avoid making a mess into the kitchen. Or D. So she can win a cooking competition. The correct answer is so she can choose the best cooking method for the chicken. And that wraps up today's lesson. If you enjoyed this video and want to see more content like this, don't forget to hit the subscribe button and ring the bell so you never miss an update. Thanks for tuning in, and I'll see you in the next video. Thank you!